refraction by lenses. That's the area we are going to look into. From the figure shows the geometry of image formation by a double convex lens. The image formation can be seen in terms of two steps. The first refracting surface forms the image I1 of the object O. Here is the object and you got the image I1 here. The image I1 acts as a virtual object for the second surface that forms the image at I. You can see it here. Applying the equation 3 to the interface ABC, we get N1 divided by OB plus N2 divided by BI1 is equal to N2 minus N1 BC1. Here is equation 3. Refraction at the first spherical surface is shown here and refraction at the second spherical surface is shown here. A similar procedure applied to the second interface A, B and C. So this one indicates this one and this one indicates this one. So minus N2 divided by DI1 plus N1 divided by D1 DI is equal to N2 minus N1 divided by DC2. Note that now the refractive index of the medium on the right side of ADC is N1, while on its left is N2. For the DI1 becomes negative as the distance is measured against the incident light. Here is the two equation. For a thin lens, BI1 is equal to DI1. So adding equation 6 and this is 7, we get N1 plus divided by OB. So 6 with 5, you'll be getting this equation. So N1 divided by OB plus N2 divided by DI is equal to N2 minus N1 into 1 by BC1 plus 1 by DC2. Suppose the object is at infinity. Therefore, OB becomes infinity and DA is equal to F. This one is equation 5 and it's not 7. So N1 divided by F is equal to N2 minus N1 into 1 by BC1 plus 1 by DC2. The point where image of an object placed at infinity is formed is called as focus F of the lens and the distance F given its focal length. A lens will be having two foci or foci F and F dash on either side of it by the sign convention BC1. So here is B, C1 is considered as R1 and DC2 considered as minus R2. So equation 8 can be rewritten as this one. So here instead of BC1 and DC2 you are able to write R1 and R2. So N21 is equal to N2 divided by N1. This is the refractive index. So equation 9, this is called as the lens maker's formula. So replacing this N2 minus N1 with N21 minus 1. So this is called lens maker's formula. So lens maker's formula It's nothing but it is useful to design lenses of desired focal length using for surfaces of suitable radii of curvature. So note that the formula is true for a concave lens also. In that case, R1 is negative and R2 is positive, and therefore F is negative. So this is equation 7, which we have seen before itself, and this is your equation 8, and this is the final equation. So the final equation is N1 divided by OB plus N1 divided by DI is equal to N1 divided by F. Replacing N1, 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 you got its removed. Again, in a very thin lens, approximation B and D are both close. This one and this one is close to the optical center of the lens. Applying the sign convention, you got U here, it's V here. So 1 by V minus 1 by U is equal to 1 by F. So this is the equation. So equation 10 is the familiar thin lens formula. So we derived it for a real image formed by a convex lens. The formula is valid for both convex and also concave lens and for both real and also virtual images.